Hi everybody, this is Cody Jackson for Codamom, and we are continuing our Python journey in object-oriented programming. This is part 3, and we're going to talk about properties and static and class methods today. You've seen it before, you'll see it again, and I'll say it again. If you want to follow along at home, here's the books that we're going to be using in this series. We are right about halfway through the Learn Programming in Python book. I will say that, especially for this video, there is some material that I'm not going to cover that is covered in the book. So if you want to get the full information, I recommend taking a look at the book. Otherwise, you'll have to find an alternative source for that. So we're going to jump into properties. Properties are what you would find as getters and setters in other languages, and as the name says, they get or set data, modify data. And it's basically a way to avoid direct access to variables. So if users of your code, not necessarily end users, but other developers, are using your code, previously, they would directly access your variables. Direct access to variables without going through some sort of an interface can cause problems because they can provide variable data that is not vetted through your system. So they could do like SQL injections, or they could use inappropriate characters, things like that. So by using getters and setters, what that does is it prevents users from directly accessing those variables, and the only way they can then interface with them is through your methods. And your methods can provide some additional functionality to verify the data that's being set, or prevent inappropriate getting of that data, or when it's received through the get method, it will format it in such a way that it's usable. So for example, if you were getting an XML document, you may convert it from XML into some sort of human readable form, if that was what the get method was designed to do. One of the problems that Python tries to fix is causing too much heartache on the user when it comes to getting and setting data. If your program originally used direct access variables, and then you move to get and set methods, your users would have to go through and change all of their code that was relying on direct access and change that to use the get and set methods. Now, while your get and set methods may only be a small handful, for the end user, you're talking tens, hundreds, possibly even thousands, depending on how big their code project is, in places that they have to change. And obviously that's frowned upon unless we're talking about a major release that does not guarantee backwards compatibility. So Python properties rely on built-in Python functionality to provide that get and set, and therefore there's no special methodology or functionality being performed. Users don't really have to change anything. They still access the data in the same way, but Python on the back end does its magic to handle whatever needs to be done, so that the end user is effectively working with a black box and they just get the data that they want, and that's all that really matters. All right, so we're going to jump over and look at some code now instead of just talk about it. So I've created a class, tempf, so this is basically temperature in Fahrenheit. We've set an initialization method that uses temp as a initialization value, and we're setting a default value of 72 for that. And then the temp argument that's coming in is set to self.temp. So that's going to be the temperature of any instance of the tempf class. We're also defining another method to Celsius, and that's going to perform a calculation for us and return the Celsius value of whatever Fahrenheit temperature is set for self.temp. We create an instance of temp F right here in line 4, and just to confirm that that's been generated within memory, we can do a print T, and that shows us that we have a temp F object, meaning an instance of the class, at a particular memory space. If we access the temperature value that is associated with this particular instance, we see that it's returned as 72, as it should be, because that's the default value. If we change the value, then we change it to 50, and then we run a 2 Celsius conversion, we'll see that the value comes back as 10 Celsius for a temperature of 50. All right, so now we're actually going to show a traditional get set method use. So we have our tempf class, but we've changed some stuff in it. First, we've defined a setTemp method, and we've defined a getTemp method. The setTemp takes a temperature argument, checks to see if it's less than absolute 0 in Fahrenheit, and if so, then it raises an error. Otherwise, it just goes ahead and returns that, sets that temperature value to a variable. The variable is not what we were working with before, which was just the regular temp. It's actually underscore temp. I don't recall if I've talked about the underscores. Regardless, if you have an underscore name, variable name, that underscore tells Python internally that it should treat that variable as a private variable. Other languages, such as Java, actually have a public tag, a private tag for variables. So if you tag something as public, then it can be used anywhere within the program, almost like global. But private means it's only internal to that class or that function or whatever. Right? Java's object-oriented, so it'd be a class. But Python doesn't have that hard and fast demarcation between what's public, what's private. If you know the name, then you can access it. The underscore tells Python to treat it as private, and so if you're using an IDE that is familiar with that, it will flag attempts to access these variables directly using the underscore. And basically remind you, you need to be looking at some sort of a get set method to access them. That's all we're doing here, is we are saying that within this class, the temperature variable itself is considered private to just this class. And so you should not be receiving, or you should not be accessing it directly via underscore temp. You need to be going through either the get temp or the set temp methods. And you'll see that we use the same thing when we are working with the get method. It is returning the value of underscore temp, and then from there you can use it however you want. So jumping back to the beginning, our initialization and our 2 Celsius methods call the getters and setters directly. So the initialization does the same thing. It sets our temp, our self.temp value, but it's actually using the setTemp method to do that. So this would be the exact same thing that you would see previously, disregarding the underscore, but we're doing it via a method this time instead of directly within the initialization. And setting it to a Celsius value, we are getting or we are using the getTemp method to do that. So moving on, line 17, we set another instance of tempf, and if we call the getTemp method, the getter, we get back our temperature, our default temperature that we set up here. And if we try to set the temperature to something lower than absolute 0, you'll see that we get the normal trace back of whatever our error message is that we told it. In this case, it's going to be a value error, which is raised, and then the message that we provided. We set it to a reasonable value, and we can get it, and we can see that it has been changed. Now, notice that we don't have anything in here telling us if the value that's returned is Fahrenheit or Celsius. We would have to know that simply by doing this. Obviously, that's not bad code production. You need to have something that tells you 32C, 42F, whatever the case may be, so you know what value you're working with. Doesn't matter for this project, just letting you know, as a good programming practice, make it obvious to what the user is doing with your code. So, if we call just the regular temp value, the temperature variable, like we did last time, then it tells us it doesn't exist. And that's because the temp variable is private, it's hidden, and literally and legitimately there is no temp value for this class. It's actually underscore temp, which we can call directly if we know that it is using underscore. So what this demonstrates, apart from the getters and setters, is that for the user, they may know that you have a particular variable name that's being used in there, but if they don't know that it's using an underscore, they're not going to be able to access it directly. And so that's a little bit of help to segregate your code so that users are only able to use the portions that you want them to do. So now to using properties. So for Python, because we're using properties, you can work like we did originally. And just for comparison, I'll put our original code up here at the bottom, and you can see that originally our initialization value, we set a argument and a default value for that argument, and we're just calling self temp equals temp. So the instance variable is the argument variable, and then we have a toCelsius method that takes that instance variable and then calculates it into Celsius for us. In our properties, we're doing the exact same thing, except that we are adding the underscore temp to signify that the value is private. You don't have to use an underscore, but it is encouraged to prevent direct access to your variables and require the individual to go through the proper methods. So what's new is we have a property, and it's signified by @property. This is a decorator. I think I talked about them, but if not, a decorator is just a @ symbol with a name associated with it for that particular property that's being used. And there's different types out there. The most common that you'll see, though, is @property, because it is used very frequently for getters and setters. So if we define a getter as a property, then all we have to do is provide what is that getter going to do. In this case, if we call for a temperature, it's going to return whatever that temperature is. So this is a very simple method. All it's doing is, if the value that comes in is temp, then return self underscore temp. Return the instanced value for temperature. To set the temperature, it's basically the same thing. Temperature is what is being recognized, and we are taking a value for temperature, and then we are just assigning that value to the temperature. So there's really nothing special to it, and you know, in terms of what's different up here versus what's different in our original code is primarily the use of the underscore and explicitly defining a property value and setter for our temperature rather than allowing direct access. So we create an instance of tempf, and rather than doing it as a separate step, we are going to give it a new value for temperature. So instead of the default of 72, as part of the initialization, it sees that we are providing that argument to it, and so it's going to go ahead and establish that for us, which we can verify by calling the temperature. And we see that the temperature was changed to 92 in this case. We can change the temperature traditionally, where we have an equal sign, and it will change the value that way. And all it's doing is just calling the setter value, and it sees that temperature is the variable that's being touched, and so it's just going to set the instance value for the variable as 48. We can still call the toCelsius method, and it will calculate it correctly using that particular instance. So now that you've seen them in practice, I'm just going to do a short little sidestep and provide a little bit more information about decorators. Now that you've seen them in practice, we can understand what's going on. So decorators basically wrap a function within another function, and that second function is hidden by the decorator name. So what's actually going on underneath the hood of Python is we have our function that we've created, temp, and it's actually being wrapped by the under the hood actions of what property does for Python. So what happens is when we call temperature, it's actually being caught first by property. Property does whatever it does under the hood, and then returns us back to our function, and then allows us to carry on that way. And same thing with the setter. In conjunction with the at property, it knows that the name that we defined for the property method is what we're going to be looking for to set, and then we just go ahead and provide the functionality for the setting. Again, it's captured first by the under the hood functionality that Python provides, and then passes it on to our function that we've created, or method in this case. Later on down the road, we'll have a video that goes into deep discussion of how the wrapping of decorators occurs to Python, but it's beyond the scope here. Just recognize that, at least for getters and setters, you just need an at property and a at property name dot setter to do the work for you. Moving on, we're going to talk about class and static methods. So what we've seen so far are instance methods. Those are methods that are individual to a particular instance. There's no data sharing. There's nothing going on. That instance has access to everything that the class has, but it is unique to that instance. If you have 3 different instances, each of them can be doing different things with those methods. To use a method, you have to create an instance. Even if you're not going to do anything further with the instance, you just want the access to the method, you still have to create that instance. So a class method doesn't require an instance. They are methods that are called on the class itself rather than a particular instance of that class. The class methods don't know about instances at all. And so even if you try to use them with an instance, you're going to get an error. It only works with a general call to the class. Static methods apply to all instances of the class rather than a specific instance. And so you can use them on any instance, the class itself, a subclass of the class, and things like that. So it's kind of a catch-all method that applies to basically anything that class relates to, whether it's the class itself, an instance of the class, things like that. We are jumping into PyCharm instead of IPython, so you can kind of see everything that's going on and hopefully a little bit better way. So we've created the class dog, set a initialization method where we have breed and age coming in as arguments, and they are setting private variables for breed and age. We have properties for the age and the breed, and just returning the age, setting the age. So you can either call the properties in here when you are initializing, or you can set them normally. It's recommended to use properties to do it, but I wanted to show you that it's not necessary if for whatever reason you forget or you choose not to, or however you want to. So moving on, we have a static method, howl, which returns aru. Now notice that as a static method, it doesn't have self in here. That's because it's a static method. It can be used for classes, it can be used for instances, and so it doesn't need to know if it's self, which would be an instance, or class, if it's a class. We have a class method, which is only for a class, and so instead of having self, it uses class as its first argument. If the name of the class is dog, so if it's a generic class, meaning this class here, then it's going to return a print statement of basically it's a mutt. Otherwise, if we have created a special class like a subclass, then it is going to return the name of that subclass. And here we have a representation which basically says, how do you want to show this dog class if called by itself? In this case, we want it to return the breed and the age. Now, if you remember, when we would try to call a class directly, it would just tell us that the instance of the class that we were calling was a memory location. It wouldn't tell us anything about that instance or anything like that. So that's what the representation method does, is it eliminates that showing of the memory space and gives us the text that we want. Before we get into how to work with the class and static methods, I want to talk about a little bit of Python administration, if you will. So over here, you'll see that we have our Python videos project, and we have our old exceptions file that we were using when we were talking about exceptions. We have our current class and static methods file, which is this one over here for the dog. And there's, within the Python videos directory, you'll see we have a init.py file. If we open that up, it's empty. There's nothing there. For Python, if you want to import modules, meaning classes and things like that, from other files, especially if they are not in your current directory and in a separate directory, that separate directory has to have the init.py file, empty or not. I mean, you can fill it with normal initialization stuff. More commonly, it's empty. And that initialization file for the directory tells Python that everything within that directory, all of the Python files, are to be considered modules and therefore importable into your code. So, if we launch a Python console, an interactive console, and we want to import the dog class that we created, we go to our class static methods, and then we import dog from there. And that way, we are able to access that dog class within our Python console. If we did not have init.py within our directory, it would tell us it has no idea what we're talking about, and we would not be able to access it directly without going to that directory and working with it. Now, granted, we are in the same directory, but we are effectively within a different environment. This goes back to our namespace discussion. The namespace for the dog class of class static methods file is a different namespace than what the Python console's namespace is. So the Python console's namespace knows nothing outside of it unless we have that init.py file telling us that the class static methods file is a namespace that is importable. That probably doesn't make sense, but as we go along, you'll see more and more examples of it, and hopefully it will start to make sense to you as we go through it. For now, just recognize that, generally speaking, you want to have a empty init.py file wherever your Python files are located to allow those files to be imported in. Back on track. We've imported dog, so now let's work with it. So we create a new instance of dog. In this case, we're calling it Lucky, and we are providing the values of the breed collie and the age 3. And in PyCharm, happens to show you over here what all of your variables are that you're working with, and so you can see what's going on. It knows that collie is a string and int is a 3. If we print lucky.breed, it uses the property functionality to return that to us. Now, if we wanted, we could also call it directly with the underscore, but it's going to let us know that that is accessing a protected member of the class. This is what I was talking about when I said if you're using an IDE that is aware of how Python works, in this case, PyCharm is going to let us know that we are trying to access a private member of the class dog. It won't stop you from using it, but it at least tells you, hey, you're doing this wrong. You might want to check what you're doing. All right, so I had a little technical problem, and so this looks a little bit different than what we just saw. So we just saw that we can take a look at the properties of Lucky, which is an instance of dog. If we try to take a look at parts of the dog class itself, it's going to tell us. If we try to access the parts of the dog itself, dog class, if we're using the properties, then it knows how to use the properties. But if we try to access parts of the class itself, then recognize that it can't do that because the class itself cannot have those attributes. So you can't access age through either the underscore age or the not underscore age. Those are both considered invalid attributes. And if you try to call it through the property only works for instances. So if you try to use gives the dog age up here through the property method, then it's only going to give us the property object, but it's not going to print it out like it did for Lucky. All right, so if we use our Lucky instance and we want to use the static method howl, then it works. It's a static method, so it doesn't matter. So if we try to use it for dog as a class, it's going to work just as well. So static methods don't care about whether it's an instance, whether it's a class, whether it's a subclass. It's all going to work for that entire hierarchy of data structures. So if we create a subclass of dog and just call it boxer, and then we inherit everything, and we're not going to provide any new functionality for it, then we can see that it will provide everything that the parent class provides. Now, so we've created an instance of our boxer class, and now we just want to see how a class method works. So if we print Lucky type, then it returns it's a mutt. If we print boxo type, then it tells us it's a boxer. The class method that we defined says if the class that's being looked at by our class method type, if the name of the class is dog, so the generic class that we've been working with, then it's going to say it's a mutt. Otherwise, if it's a subclass, then it's going to return the name of that subclass, and that's what it did down here, where our generic Lucky is a mutt, but boxo is a boxer. And so that's it for this video. Oops. So we talked about properties, how they work like getters and setters in other languages, but kind of improve on it by allowing users of your code to access variables like they normally would, and Python uses its built-in functionality to allow the user to work with those as regular variables without having to mess with additional overhead of traditional getters and setter methods. We also looked at class and static methods. Static methods are used for any part of a class, a subclass, or instances of those classes, whereas a class method can only work with the class itself, and it doesn't know anything about instances of that class. Next time, we're going to take a look at files, and then after that, we're going to take a brief look at databases, and then that's pretty much it for all of the preliminary basic Python stuff. After that, we're going to look and create a full-fledged program using all of the stuff that you know now, as well as some new stuff that has come into the Python language since I first wrote the book. So I hope you enjoyed this video. I hope you learned something from it. Let us know comments, concerns, questions in the YouTube comments. And until next time, have fun and keep learning. Thanks.